Hi everyone. Tonight we're going to be talking about the different forms of lines or forms of linear equations that we would deal with. So there's three main ones that we're going to work with in this chapter. The first one is what's called point-slope form, and you've all probably seen these before. Point-slope form is y minus y1 equals m times x minus x1. And in this case, m equals the slope of the line, and x1, y1 equals a point on the line. The general form, the y and the x are always going to be in this equation. It's just a y and an x. It holds the place there. The y1, the m, and the x1 will actually have values to put in there to evaluate for. So we're pretty used to seeing a point, thinking of the coordinates as x1, y1, plugging them in here, and seeing slope as a value to put in for m. The main thing that we're going to have to do here is we distribute this m, and then we're going to simplify by pushing this y1 over to this side. And the reason we do that is because most frequently we like to be in slope-intercept form, which is y equals mx plus b. And in this case, m is the slope still, and b is the y-intercept. This is the easiest form to graph from because just like we did yesterday in our video when we were talking about slope, we picked like a point on the line, and then we determined the slope by we determined the graph of the line by using the slope to move from one point to the other, and then we just connected the dots with a line. So if we have the y-intercept, we have a point on the line. If we have the slope, that tells us how to move from one point to the other, and then we just connect the dots. The y and the x are just there, right? So it's y equals mx plus b. Here's a point on the line. Here's a slope. You can do the same thing here with point-slope form. You have a point on the line, you have a slope. But it's easy to identify. It's nice usually to identify the intercept. So you can move from point-slope form into slope-intercept form, like I said, by distributing the m and then simplifying by moving over the y1. And when you combine that m times negative x1, or the opposite of x1, and then you add over the y1, that becomes b. Another thing, or another form, I should say, of lines is the general form, and we call that capital AX plus capital BY equals C. And so in the general form, the reason we like to use that is because it's nice and easy to determine both our x and y intercepts. So if you remember from the video on intercepts, the y-intercept is where the x value is 0, and the x-intercept is where y is 0. So we can also graph a line by just plotting the x-intercept and the y-intercept and connecting the dots there. When it's written in general form, it's easy to do that because you plug in 0 here and it kind of eliminates this term, and so now you're just dividing both sides by b to figure out what your y-intercept is. Or if you want to find out what your x-intercept is, you plug in 0 here and it'll kind of cancel out this term, and you just divide both sides by a, and that gives you your x-intercept. And then you got two intercepts and you just connect the dots. So these are all forms of lines, linear equations that we like to work with, and we're just going to do some examples tomorrow when we're working in class of graphing, giving these different forms. Hopefully you've seen them all before, and it's somewhat of a review for you. When we talk about parallel and perpendicular lines, those are two different relationships we think of when we're graphing lines. So two lines are parallel, which means they never touch, and you can think of the two L's in the word parallel to help you identify the concept. The two lines are parallel if their slopes are the same, but their y-intercepts are different. So if I have something like y equals negative 1/2 x plus 4 and y equals negative 1/2 x minus 3, those are two parallel lines. And I see that immediately because I notice that both their slopes are the same, negative 1/2, negative 1/2, but also both their y-intercepts are different. So plus 4 and negative 3, right? Because these are in y equals mx plus b form. So here's the m, negative 1/2, and here's the y-intercept, the plus b is 4 here and negative 3 here. So the slopes are the same, y-intercepts are different. Two lines are perpendicular, that should be if their slopes are opposite reciprocals of each other. And what we mean by opposite reciprocals means the signs change, so one is positive and the other is negative. And the reciprocals mean that the numerator and denominator in one flip, and it becomes where the denominator is now the numerator and the numerator is now the denominator of the second fraction. So to visualize or think of an example of this, if we have y equals negative 3/4 x plus 2 and y equals 4/3 x plus 7, that I can identify as perpendicular lines. Their y-intercepts are most likely going to be different, but really what we're looking for is the opposite reciprocal when we're looking for the slope, right? So negative 3/4 and 4/3. They do not necessarily have to have different y-intercepts. It could be the case that these two lines that are perpendicular actually intersect at the y-axis, so that's why that is not part of the definition. So if two lines are perpendicular, I should maybe talk about that. They meet at a right angle, so they are definitely going to intersect. They'll make like an X, so two lines are perpendicular if they cross, and where they intersect forms a right or 90-degree angle. So opposite reciprocals. Something that's a little tricky to think about is if one of the slopes is a whole number. So if I have something like y equals 2x plus 1, the perpendicular slope of that, remember that a whole number when it's written as a fraction is really like over 1. So that would be 2/1. So a perpendicular line to the line 2x plus 1, the perpendicular slope would be negative because this is positive. We want the opposite, it's negative. And if this is 2/1, its reciprocal is really 1/2. So we'd have something like negative 1/2 x plus 1. So like I said, if the y-intercepts are the same, then that means that's where these two lines intersect. And so this has an opposite reciprocal slope of this line, so that's why we would know that these two lines here are perpendicular. Sometimes you'll have examples where it says find a line parallel to the given line and through a certain point. So let's do one of these. Let's say find the equation of a line that is parallel to y equals 3x minus 4 and through -1, -6. Okay, so I want to find a line. I want to find an equation of a line that's parallel to that. So what information am I given? First of all, I know that m is got to be 3. It's got to be the same as this line because it's parallel, and we know parallel slopes are the same. Now the other bit of information I have is an x1 and a y1, which means I can use the point slope form, which is y minus y1 equals m times x minus x1 to write the equation of this line. I have m, I have x1, and I have y1. So I would proceed by plugging these values in. So I would say y minus y1, which is -6, equals m. I should fill that in. I know what m is, actually. Equals m, which is 3 times x minus x1, which is negative 1. And now I'm going to simplify this. I have y plus 6 equals 3 times x plus 1. And I always want to move, even though now I do technically have an equation, it's in point-slope form, I always want to end up in slope-intercept form because that's just the most common form of a line that we're going to use. So first thing I'll do is say y plus 6 equals 3x plus 3. I'm going to distribute the m across the x and the x plus, or the x1. So 3x plus 3, and now I want to get y by itself on the left here, so I'll subtract 6 from each side, and I'll have y equals 3x minus 3. And so that is the equation of a line that's parallel to 3x minus 4, y equals 3x minus 4, and it's through this point, negative 1, negative 6, right? So their y-intercepts are actually very close. This is just moving, basically taking this line and shifting it all down, down 1. So that's how you would determine a line parallel to a given line and through a specific point. So why don't you try one here? I'm not even going to show you the solution. You'll have to bring this to class tomorrow. So find the equation of the line that is perpendicular. So think about what that means in terms of the slope. So perpendicular to y equals negative 3x plus 4 and through the point 2, negative 6. Okay, so find the equation of a line perpendicular to y equals negative 3x plus 4 and through the point 2, negative 6. Try that on your own. Bring that with you to class tomorrow, and that's where we'll start. So have a great night, and I will see you soon.